All right, let's finish up the chapter today. We're going to do so by talking about periodic trends. We can use the periodic table to find 3 different trends we're going to talk about today. So please have your guided notes open and ready to fill them out. Okay, we're going to use the periodic table to discover 3 trends. Number 1 is atomic radius. How large the atom is, from the nucleus to the outside of its electron cloud. Also, we're going to talk about ionization energy.
What?
Ionization energy. And then finally, electronegativity. So a couple things you need to have out. One is a periodic table. So make sure that's out. And your guided notes. Please have them out and be filling them in. Okay, so let's talk about atomic radius first. Atomic radius, this graph right here, if you look at this graph, guys, here's a hint. Whenever you take the ACT, on the science section, it's all graphs. What I would do first is identify what the graph is and look at the axes. Okay? Looks like it's plotting atomic radius on the y and atomic number on the x. What happens as you go from 3 to 10? What's the trend? Atomic radius does what? It gets smaller, it decreases. Well, let's look at the periodic table. Hopefully you have yours out. 3 is lithium. As we go across to neon, which is number 10, the atomic radius gets smaller as you move to the right. Doesn't it? It does. And then it jumps from 10 to 11. So 10 was neon, 11 is sodium. How come you think it got so much bigger at sodium? What's your hypothesis? Why do you think it's getting bigger?
The energy level.
Good. We just added another energy level. We went from 2 to 3. And then it decreases again. And then it jumps. And then it decreases again. Okay, that's the trend. So, let's look at the trend here. Atomic radius, you're supposed to write down the definition. Here it is. Atomic radius is the distance from the center of the nucleus to the outermost orbital. Now, if you look at a circle, the center of the nucleus is here to the outermost orbital. That's what radius means. Okay? A lot of people get that confused with diameter. What's diameter?
All the way.
All the way across. But the radius is just from the center to the outermost orbital. Okay, here's the trend. You're supposed to write it down. Radius decreases across the group. So as you go from left to right, it decreases. How come? Well, when you move across the group, you're adding protons. More protons in the nucleus pulls those electrons tighter. So it pulls them in so you get a smaller radius. Also, you're supposed to write this part down. Radius increases down a group. Okay, so as you move down on the periodic table, down this way, it increases. How come? Because you're adding another shell. You're adding an energy level. You're adding another shell of electrons. So it gets bigger. All right. If this is our periodic table, I think it's useful to draw the trend with one arrow. Where on the periodic table will they be the smallest in terms of radius? The top right is small. Okay? And where are they going to be the largest?
Bottom left.
Okay, so if we draw an arrow from the smallest to the largest, it's going to look like this. Okay, starting in the top right and going to the bottom left. So that's the trend I would remember. It's easy, just one arrow. Okay. Here's a graph that shows that. What's the smallest element on the periodic table in terms of radius? That'd be helium. Which one's the largest? It doesn't show it here, but francium is actually underneath cesium. But you can see, as we move this way, they get bigger. And as we move down, it gets bigger. So, practice problem number 1, it says to draw an arrow on the periodic table below that points to the elements that have the largest. Again, you're just going to start up here and draw an arrow to the bottom left. Put small up there and large down here. So francium, Fr, is the largest in terms of radius. Helium is the smallest in terms of radius. Okay, practice problem number 2. Which of the following atoms would have the smallest atomic radius? Let me point them out for you. Sodium is right here. Rubidium is right here. Potassium is there. And cesium is here. Now again, let's draw that trend. This is where they get bigger. Which one is going to be the smallest in terms of atomic radius? Okay, so if you said sodium's going to be the smallest because it's closest out of all of these. It's closest to the top. So that one's going to be the smallest. Yeah?
Black people get sunburned.
Oh, Brandon. Okay, moving on. Okay, practice problem number 3. Now, you guys try this one on your own. Let me point out where they're at, though. Carbon is right here. Oxygen is right there. Lithium and fluorine. Where's fluorine now? Okay. Okay, so if you're watching the video, please hit pause. Answer this question. Now, we want them in order of increasing atomic radius. So from smallest to largest. Please come up with an answer and then hit play. Hit pause. Okay, let's see if you guys got this one. Again, if I was to draw the trend, here's the trend on the periodic table. These are large. These are very small. Okay, we want it in order of increasing. So we're going to go from smallest to largest. Did you guys say fluorine first?
Fluorine.
Then what? Oxygen, then carbon, then lithium would be the largest one. Okay? So that would be the correct answer. Hey, this is pretty easy stuff, isn't it, guys?
Yeah, it is.
This is simple. Okay, let's go to the second trend. This one is called ionization energy. You're supposed to write down the definition. There it is. Ionization energy is the energy required to remove an electron from an atom. So it's this energy required to remove an electron from an atom. We haven't talked about this yet, but you can remove electrons from atoms. You can pull them away. And so there's a certain energy required to do that, and it's called the ionization energy. Here's the trend. You're supposed to write it down. It tends to increase across the period. So as you go from left to right, it gets bigger. And it tends to decrease down a group. So as you move down, it decreases. So if you have your periodic table, here's how the trend would look. It's small right here, but it's very large up here. So guys, how does that relate to atomic radius? It's exactly opposite atomic radius. So if you remember that it's exactly opposite of radius, that's pretty easy. Okay, all of these guys are small. As you move up and to the right, it gets larger. Okay, so let's go through practice problem number 4. Draw an arrow on the periodic table that points to the elements that have the largest ionization energy. So we're starting here at smallest, and it's going to point up to the top right. Okay, we're going to use that trend to answer a few questions, just like we did with radius. Okay, practice problem number 5. Which of the following atoms would have the largest ionization energy? Let me point them out. Chlorine sits right here. Aluminum, barium, and cesium. Okay, remember the trend. Now I want the one with the largest. Will, what do you think? Which one's closest to the top right?
Chlorine.
Chlorine, you're right. Chlorine. How many of you guys got that one right? Very good. Let's try another one, okay? Practice problem number 6 says list the following atoms in order of decreasing ionization. So this time we're going from largest to smallest. So let me point them out. Here's oxygen, iron, strontium, and francium. So I want order of decreasing. So largest to smallest. If you're watching the video, please hit pause and answer this before we go over the answer. Okay, let's see if you guys got it right. Remember, the trend goes like this. So this is large, this one's small. We want it in order of decreasing ionization, so largest to smallest. Which one's first then? Which one's the largest?
Oxygen.
Oxygen, then what? Then iron, then what? Strontium, then francium. Very good. Okay, and we got it right. Okay, one last trend and then we're done. This one's called electronegativity. Electronegativity is an atom's attraction for electrons. So it's how strongly it attracts electrons to itself, to the atom. It's an atom's attraction for electrons. Okay, here's the trend. It tends to increase as you move it across a period. So as you go from left to right, it increases. It also tends to decrease down a group. So as you move down, it decreases. So we got the trend. Okay, this one is going to look just like, which one? It's going to look just like ionization energy. Okay, it's going to get very large on the top right, and it's very small at the bottom left. So which one is not like the other?
The first one.
Atomic radius is different. The other two are just the same. That's a good way of remembering it. Radius is the one that goes opposite of the other two. Okay, so electronegativity. What is it, guys? Jager, what is electronegativity?
Like the attraction an atom has for electrons.
Yeah, it's how strong an atom pulls electrons toward it, right? Okay, on your periodic table, the one that I gave you guys, if you look at it, pull yours out, the one that I gave you. There's a spot on our periodic table where it has electronegativity in it. It's the bottom right number. So for example, what's the electronegativity of nitrogen? 3. What is it for oxygen? 3.5. What is it for fluorine? 4. What is it for sodium over here? 0.9. So our periodic table has these values. Sodium is 0.9, carbon is 2.5, 3, 3.5, and 4. So you'll notice the trend, it does go like this. It gets larger as you move up and to the right. So let's go through some practice problems. Number 7. It says draw an arrow on the periodic table below that points to the elements that have the largest. Okay, so we're going to start down here at francium. And it's going to point up here toward helium. They're the largest, and down here are the smallest. Okay, now that we know the trend, let's answer some questions. Number 8. Which of the following atoms would have the smallest electronegativity value? Let me point them out to you. Okay, so magnesium sits right here. Calcium sits below it. Strontium is below it. And barium is the bottom one. Which one has the smallest? Again, the trend looks like this. So, Braden, which one's the smallest here? Barium. Barium. Yep. Aren't these so easy, guys? These are easy questions, right? Yeah. Okay, let's go to practice problem number 9. It says, list the following atoms in order of increasing. What does that mean? Order of increasing electronegativity. Smallest to largest, good. So fluorine, let me point them out. Fluorine's right here. Aluminum, iron, and cesium. Okay, I'm going to hit pause. You guys try this one before you hit play, and we'll see if you get it right. Okay, let's see if we got it right. Again, the trend, what I like to do is draw the trend in. That's the trend. So if we want to go from smallest to largest, which one's smallest, guys? Cesium. Then what? Then iron. Then what? Aluminum. And then the largest? Fluorine. Nobody should miss the electronegativity trends, because aren't they on your periodic table? Yeah, all you have to do is look at the bottom number there and it tells you what it is. So nobody should miss those. Okay, and yes, we got it right. Okay, there's a big diagram of this in your guided notes. Please take a second. You see those big arrows? I want you to write the trends in. Okay? So write this and all of these in those arrows. So take a second to get that written in there. Okay, so hopefully you wrote that down. But for me, when I was learning this, going through it, it was easier for me to remember one arrow rather than two. Isn't it easier to remember one thing rather than two? So somewhere on your books, let's write these 3 boxes down. So one for atomic radius, one for ionization, and one for electronegativity. And just draw in the trend. Remember, atomic radius was the only one that was different. It got bigger or larger as you move to the bottom left. But the other 2 are exactly the same, but opposite. Isn't that good, Will? Isn't that easy to remember one arrow? For me, that was easier. So hopefully that helps you remember these trends, because you will be expected to know where on the periodic table are the atoms the largest in terms of radius, ionization energy, and electronegativity. And be able to list them, just like we did on our practice problems.
So it changes?
Okay, so draw those trends in. I think that will help you more, just remembering one arrow. Okay, we've got one small section left with the notes in this chapter, and then we're done. So stay with me for 10 more minutes. We'll probably have it done. Okay. This section is on atomic radii, but it's ionic radii. Let me get all this stuff up here and then we'll talk about it. Okay? So this is brand new stuff. Please pay attention as we go through this. Okay? There's these things called cations. And there's things called anions in chemistry. We haven't talked about this before, but atoms can lose or gain electrons. And when they do, they're called different things. So let's look at cations first. Cations are positively charged ions formed when an atom of a metal loses one or more electrons. So if we have a metal here, let's say magnesium. How many protons does magnesium have? It sits right here, guys. How many protons? 12 protons. And protons have what charge? They're positively charged. How many electrons would it have? It would have 12 electrons. And electrons have what charge? A negative charge. And so overall, what's their charge of that? We have 12 plus and 12 minuses. So what's the overall charge? 0. So it's neutral. But what if I took one of those electrons away from magnesium, so magnesium was to lose one of those electrons? Let's say it loses 2 electrons. So now it only has 10. Now it only has 10 electrons. Now what would its charge be? A 2 what? A 2 minus. Or would it be 2 positive? What would it be, guys? I've got 12 positives and 10 negatives. So it's what? 2 positive. So we'd say it's a +2 charge. Okay, when that happens, we call that magnesium with the 2 plus charge a cation. It's positive. And cations tend to be smaller than the corresponding atom. And we'll talk about that here in a second. Okay, now let's go to the opposite. Let's talk about anions. Anions are negatively charged ions formed when a nonmetal atom gains an electron. Okay, so for this one, I'm going to use fluorine as an example. How many protons does fluorine have? Fluorine. 9 protons, which are positive. How many electrons would it have? 9 electrons, which are negative. So for an overall, what's its charge? 0. It's balanced. But fluorine really wants to gain 1 more electron to become like a noble gas. So if it did gain an electron here, it wouldn't have 9, it would have 10. Now it's got 1 more negative charge. So what's its overall charge going to be? A -1. When it does that, we say that fluorine is an anion. And it's negatively charged. And since you added 1 more electron, they tend to be larger than the corresponding atoms. Now, when I was learning chemistry, I had a hard time keeping this straight. Was cations positive or negative? Was anions positive or negative? My chemistry teacher taught a cool way to remember that. So here's how she related that to us. Okay, there's this cat. Okay, I'm not very good at drawing, but this is a cat. Okay. Is it a good cat? And it was a happy cat until it went out into the road. Okay? It went out into the road, and what happened to it? These are tire tracks. Okay? It got ran over. And since it got ran over, you go out there. Hey, stay with me. You go out there, and it's not a happy cat anymore. In fact, its eyes have turned to crosses. It's dead. Okay, so it's not a happy cat. But, so his eyes were crosses. Here's how this relates to what we're talking about. This is a cat, so cations have what charge? A positive charge. How do we remember that? Because the eyes, when it got ran over, went to what? Crosses, which are like plus signs. Okay. Cat, guys, think about this. Cat ions, like not these kind of eyes, but these kind of eyes. The cat ions went to plus signs. They went to crosses. Okay. So, what charge would an anion have then? You just remember that's a negative charge. All right, a couple more slides and we're done. This is a good table that kind of shows us what's happening here. If you lose an electron, you become positive. If you lose an electron, are you going to be larger in terms of radius or smaller? If you lost an electron, well, it's smaller. If you just have the normal lithium atom, the radius would be this. But if you lost, you become smaller. Now, what happens if you gain an electron? If you gain an electron, you get a negative charge. What happens to your radius? Goes up because you've just added electrons. You get larger in terms of atomic radius. Okay. So let's see if we've got this down. Let's do a couple of practice problems. Okay, practice problem number 10 says, which of the following atoms will have the largest, so we're looking for the largest atomic radius. Would it be the normal oxygen atom or oxygen with a -2 charge? Good. How come? Because if you add electrons, isn't it going to get bigger in terms of radius? Yeah. Okay, now is this called a cation or an anion? It's negatively charged, so it's an anion. Okay. Anions are larger. Good job. Okay, number 11. Try this one on your own. If you're watching the video, hit pause and see if you can get this one right. All right, guys, what'd you say? Which one is the largest in terms of atomic radius? What'd you say, Callie? Yeah, it's this first one. Good job. How come? Well, this one, did you take electrons away from it? Yeah, this one we removed electrons. So if we removed those electrons, we made it smaller. So calcium, the regular calcium atom, is larger in terms of atomic radius. Okay, this wasn't on there, but is this called an anion or a cation? It's a cation. Very good. Guys, that's the chapter. So before I quit the video, though, you now know enough to do another worksheet. So I want you to have more practice with this. It's called Periodic Trends Worksheet. Please go there and let's try and get that done. And hopefully this video helps you out.